This right here is a concept called lava rand. It's a bunch of lava lamps stacked up in shelves in Minecraft, because I can't afford that many lava lamps in real life. And this is something actually used by Cloudflare, the network service provider, which you might have seen while trying to load some websites, to generate truly random numbers. Truly random numbers? What do you even mean? Well, glad you asked. Let's imagine a scenario where you want to make your own game, where players can win fun prizes based on random chance. But computers are deterministic. Nothing a computer does is truly random, even when it might seem like that sometimes. This is where the concept of pseudo-random numbers comes into play. We basically need some way to generate numbers based on the following simplified criteria. Unpredictability, meaning that close numbers give vastly different results. A uniform distribution over our specified range of numbers. And also no patterns that can be exploited. Considering these criteria, the fractional part of a sine function might be a decent starting point. These values fluctuate between 0 and 1, and when multiplied by an ever larger growing number, this starts to look more and more random. At larger values, my graphing software kinda gave up, and I had to fall back to sampling the function manually, and this demonstrates the random values very clearly. Now, this is of course not perfect, but it's a good place to start for now, and additionally to our gambling idea from earlier, we can use this to generate a 2D texture using the point coordinates as color values. I will use the same value in all 3 color channels of an RGB color, so we will get a grayscale image. And we get a symmetric texture, because behind the scenes I used the dot product to turn a 2D coordinate into an input for our random number function. We can easily fix this by assigning some random but different weights to our coordinates, and boom, we get TV static. To make it authentic, we can even animate it using time for our randomness. Meaning our random value will now not only depend on the value we give it, but also a continuously changing value. This is a very general concept called the seed value. You might have seen this in games where you can enter a value which will then influence stuff like world generation, item drops and so on. At some point though, we may get a bit bored of just the TV static. We would like to have a little more control over the randomness, since by itself it just looks very chaotic and unnatural. The second point here is very crucial, so let's take a look at nature. These are all examples of randomness. Well, kind of. They do have some kind of patterns to them. So how can we make our randomness more natural like this? This is where a concept called noise comes in. A researcher named Ken Berlin asked himself the same questions back in 1980, and he came up with a genius idea. Let's take a look at this in one dimension first. Here we have a real valued function from which we separate the fractional and integer x values. The integer value is then used as an input for our pseudo-random number generator from before. You can see that we get those nice blocks every integer coordinate. Now these don't form a nice continuous pattern, which is what we wanted, so we could try linearly interpolating them. Which makes it better, but we still get these pointy vertices at specific intervals. Therefore, let's not limit ourselves to linear interpolation, since we can basically use any function to interpolate the values. A cubic one will give us some nice results here. I won't go into the details here, but you can apply the same concept to 2D using 4 points of reference instead of 2, and then use any interpolation curve you want between 2 of the corners. This way we can fill a full 2D area with our random noise pattern. This is what's called value noise. The only problem with this, however, is that this tends to produce very blocky looking noise, as you can see. To remedy this, Berlin came up with the idea to use a 2D random function instead and interpolate the vectors afterwards, which makes the results look a bit better. This is something called gradient noise, and we can already use this to make some cool effects. This was an idea I had for a 2D fragment shader, where I modified the coordinates used for drawing some straight lines over time, and I think it looks quite cool. You could also use this for more advanced topics, but let's make some improvements to our noise first before tackling any of that. Let me just show you one last trick for this video called Fractal Brownian motion. If we take another look at our 2D noise, we can see that it almost looks blurred. Kind of. This is often good, but one trick noise magicians use sometimes is layering a bunch of these noises over another. And since when viewed in 1D, our noise looks quite similar to a sum of sine waves, we will use sine function terms like amplitude and frequency to describe certain concepts here. Namely, if we add multiple layers to add details, they need to be decreasing in amplitude, since our goal is just to add more detail to the function to make it less blurry. This parameter is called gain. Two more parameters to describe this process are the number of times we do this, which is called octaves, and also the lacunarity, which is the frequency modulation of the layers. As you can see in our result, we can use this to create some different, very cool looking effects. Here's some 2D effects I created while playing around with this technique. And you can also use 3-dimensional FBM noise patterns to generate terrain or clouds. But that's maybe a topic for another video. Alright, I think that's enough noise magic for today. Thank you so much for watching. I want to do more videos on these topics, so I hope you enjoyed this slightly less pure math focused content. And stay tuned for the next one. See ya!